Hi, welcome back. I'm Mr. Peck here. Now let us learn about electric potential and potential energy. Okay, first of all, before we go into electric potential and potential energy, I want you to recall back what you have learned in gravitation. Okay, let us use this analogy because gravitation and electrostatic, what you have learned, they are similar. Okay, they have similar terms and they have similar equations. Okay, so okay, you have learned about gravitational force, electrostatic force, gravitational field strength, electric field strength. They both have similar terms and also same equations. Okay, it's just that for gravitation they use mass, but electrostatic they use charge. Okay, now let us look at electric potential and potential energy. So in gravitation, you learn about gravitational potential energy, which is a formula negative GMM over R. Okay, negative GMM over R. So in electrostatic, the electric potential energy is also equal to KQQ over R. Do you see that the formula is the same? It's just that instead of using mass, we use charge. Okay, but in gravitation, you have this negative sign, but in electrostatic, the electric potential energy doesn't have a negative sign. So be careful of that. So in gravitation, you have negative sign for the gravitational potential energy, but for electrostatic potential energy, you do not have negative sign. Okay, the formula. Now, for gravitational potential, it is actually gravitational potential energy divided by test mass. Yeah, or we can say gravitational potential energy per unit test mass. So once we divide by test mass, so the test mass gone, so the formula left with negative Gm over R. Negative Gm over R. But in electrostatic, the electric potential is also electric potential energy divided by the test charge. So when you divide by the test charge is gone. Okay, I show you. This one is test mass divided by the test mass. So that's why the formula left with negative Gm over R. But this one divide by test charge, so the formula left with KQ over R. Also, in gravitation, you have negative sign, but in electrostatic, you do not have negative sign. Okay, so this is electric potential is electric potential energy per unit test charge. I'll explain more on this electric potential, the meaning of it, yeah, later on. Now I want you to look at a unit. So gravitational potential energy and electric potential energy both have the same unit, joule. And this one is the potential, gravitational potential is potential energy per unit test mass. So that's why it's joule per kilogram. So, but for the electric potential, it is electric potential energy divided by the test charge. That's why it's a joule per coulomb because the charge is coulomb. Okay, it's joule per coulomb. Yeah, charge is coulomb. Yeah, so joule per coulomb, or you can write as volt. For potential, you can write as volt. So either unit, volt or joule per coulomb, accepted. Okay. Yes. And this electric potential energy and electric potential, both of these are scalar quantity. So scalar quantity only has magnitude. So it doesn't have direction. So you no need to resolve x and y component. You no need to draw vector diagram. You no need to find the x component and y component. So what you have to do is you just total up. You just total up. If the question asks you to find the total potential energy or total potential, you just add up. Okay. So it's different from the vector like force and electric field strength. Okay, for scalar quantity like potential energy and potential, you just total up. Okay, when the question asks you to find the total potential energy or total potential. But the thing is, unlike the vector force and electric field strength, where you ignore the sign for charge Q or test charge, okay, when you find the magnitude, you ignore the sign for the vector force and field strength. But for the scalar quantity, potential energy and potential, you must substitute the sign for the charge Q and test charge. When you want to find the magnitude of the total potential or total potential energy, you must include the sign. This one I will explain more when problem solving. Okay, so you must look into my videos of problem solving in this chapter. Okay, you must to understand more about this. Right now, you just write down as notes. All right. Okay. Let us continue to dive deeper into the meaning of these two: electric potential energy and electric potential. Okay. Now, let us look at what is meant by electric potential energy. Electric potential energy, okay, is KQQ over R. Okay, so electric potential energy, it depends on two charges. It depends on two charges. Both the point charge and test charge. So what is electric potential energy? Electric potential energy is the energy possessed by the test charge. The potential energy possessed by the test charge. Okay, it's just like gravitational potential energy. Electric potential energy is the energy possessed by a certain charge. Okay, so like you see this point charge and this test charge, both of these they repel each other because positive charge and positive charge, they repel each other. So we can say this test charge is being repelled by the point charge. So we can say this test charge, it possesses a certain amount of electric potential energy because of this repulsive force. Because if we let go this test charge, the electric potential energy will convert to kinetic energy. Because if you let go this test charge, you just let go, it will certainly accelerate away from the point charge. Why accelerate away? Because this test charge, it possesses electric potential energy. So when it accelerates away from the point charge, the electric potential energy convert to kinetic energy. Understand that? You can convert to kinetic energy. So because of the repulsive force, this test charge possess electric potential energy. And to calculate the electric potential energy of this test charge, the formula is KQQ over R without the negative sign. Okay, unlike the gravitation has negative sign, but electric potential energy don't have negative sign. Okay, and this value depend on both charge, depend on point charge and also test charge. Okay. Now, how about the electric potential? Okay, electric potential. Okay, hold on. Yeah, hold on. We can say the electric potential energy, the unit is joule. So maybe you can say this test charge, maybe it possess 100 joule of potential energy. Yeah, this test charge, it possess 100 joule of potential energy. That's it. Yeah. So if we let go this test charge, this 100 joule of potential energy will change to 100 joule of kinetic energy. Okay. Now, How about electric potential? Electric potential is also potential energy, but only for one positive 1 coulomb of charge. So that's why electric potential is electric potential energy per unit test charge. Per unit test charge. So if we divide by test charge, so the formula KQQ over R, KQQ over R, divide by the test charge. So this test charge gone. So the formula just left with the point charge, KQ over R, right? KQ over R. So because it is energy over test charge, okay? So it's that's why the formula is joule per coulomb. Yeah, energy is joule, charge is coulomb. So joule per coulomb, that's a unit, joule per coulomb for the potential, or you can write as volt. Okay, this is the test charge. Is electric potential energy per unit test charge. So maybe we can understand more if we put in values. Yeah. For example, potential. What is mean by potential equal to 10 joule per coulomb? 10 joule per coulomb. That means the potential at certain point are like this point. Like this point. Let's say this point, it is I put it here. Okay. What about this point? Yeah. Let me show you. Okay. What does it mean by potential equal to 10 joule per coulomb? Let's say this point it is 10 joule per coulomb. What does it mean? What does it mean by 10 joule per coulomb for this point? So as you can see, potential, it only depends on one charge, which is the point charge. It doesn't need to have test charge. No need test charge. But unlike the potential energy must have test charge. So if you want the potential energy to exist, first of all, you must have a test charge. You have a point charge and a test charge, then only you have electric potential energy. Then only you have electric potential energy. Then this electric potential energy is possessed by the test charge. But for electric potential, it doesn't need a test charge. It just needs a point charge. So any point around the point charge has potential. Okay, has potential. Like this point, it has potential, and the potential of this point is 10 joule per coulomb. How do we understand that? It means that if we have a positive 1 coulomb over there, okay, just right over here. If let's say I have just like the electric field strength, electric field strength is force per unit. Okay, let's go back to what we have learned in electric field. Electric field strength. Electric field strength is force per unit test charge. Like this one, 10 Newton per coulomb. That means is 10 Newton per positive 1 coulomb. That means electric field strength at this point is, let's say if electric field strength at this point is 10 Newton per coulomb, that means if I have a test charge of positive 1 coulomb, it will experience electric force, a repulsive electric force of 10 Newton. That is the electric field strength. The electric field strength, the strength of electric field at this point. Like you see, if the electric field strength over here is 50 Newton per coulomb, that means if 1 coulomb is placed over here, it will experience 50 Newton of repulsive force. So stronger electric field at this point compared to the 10 Newton per coulomb one. Okay? So electric field strength is force per unit test charge. So similar to electric field strength, the electric potential also has similar meaning. It is also the electric potential energy for positive 1 coulomb of charge. Understand? Potential is actually the same as electric potential energy. Electric potential is actually electric potential energy, but for only positive 1 coulomb. Understand that? That means if this point it has potential of 10 Newton per coulomb. That means if I have if I have on a second, if I have a positive, let's say this is a positive 1 coulomb, okay, positive 1 coulomb. That means this positive 1 coulomb test charge, it will have how much energy? It will have how much energy for this point? This positive 1 coulomb, it will have 10 joule of potential energy. You have 10 joule potential energy. That is means by potential of 10 joule per coulomb. That means it's 10 joule per positive 1 coulomb. That means if I have a test charge of positive 1 coulomb, this positive 1 coulomb will possess an electric potential energy of 10 joule. Understand that? Of 10 joule. That is mean by 10 joule per coulomb. So electric potential is electric potential energy per unit positive test charge. Or we can say per unit positive 1 coulomb. So we can say electric potential is actually the same as electric potential energy, but for only positive 1 coulomb. So since potential and potential energy, they are the same thing, potential energy is the energy for more than 1 coulomb, but potential is only the energy for only 1 coulomb. So both are energy. Potential is actually energy for 1 coulomb. Potential energy is actually energy. So both of them are energy. So both of them are scalar quantity. Understand that? Both of them they are the same thing. So both of them are scalar quantity. Why potential is a scalar quantity? Because it is actually potential energy for positive why potential is a scalar quantity? Because potential is actually potential energy for only positive 1 coulomb. Okay, clear enough. So the formula is KQ over R. Yeah, it only depends on point charge. Okay, and now I want you to I want you to look carefully. This is it looks complicated, but actually it's not. Yeah, it's very simple. Okay, I want you to look carefully. Now, first of all, this is the number scale. The number scale according to mathematics. Okay, which one is the lowest value? Of course, the most negative. The most negative is the lowest value, and the most positive is the highest value. Okay, the more and more negative means the lower the value. The more and more positive means the higher the value. So we can say positive 500 is bigger than positive 100. Okay, and also negative 100 is bigger. Negative 100 is bigger than negative 500. Understand that? Negative 100 is bigger than negative 500. Positive 500 is bigger than positive 100. Negative 100 is bigger than negative 500. Okay, enough of that. Now, I want you to, first of all, we have, as you can see here, first of all, I want you to look at the point charge and test charge. We have four situations. The first situation is positive point charge and positive test charge. And the second situation is a positive point charge with a negative test charge. The third one is a negative point charge and positive test charge. The last one is a negative point charge. This one is a negative point charge and a negative test charge. Negative point charge and a negative test charge. Now, first of all, I want you to look at the value. The value. You see that? You see the 500 and 100. This one refer to this test charge, the energy, the electric potential energy possessed by the test charge. And then this 50 volt and 10 volt. This one is without the test charge, just point. Yeah, just point. Because we know that potential only depend on one charge, which is the point charge. Potential only depend on point charge. Okay, depend on point charge. So even though we don't have any, we can say we don't have any test charge. Let's say like here. If here we don't have any test charge, there is still potential. But for potential energy, you must have a test charge. Only the test charge has electric potential energy. If there's no test charge, there's nothing there to possess potential energy. And that for potential, it doesn't need a test charge. Yeah, it just need a point charge. So if there's no test charge there is still potential. Who give the potential for this point? Yeah, it is the point charge who provide potential for this point. It is the point charge who provide potential for this point. Why it provide potential for this point? Because it is this point charge who provide the electric field around the point charge. When there is electric field, there is potential. There is potential around the point charge. Okay. All right. That if there is no electric field, there is no potential. Okay. Now, I want you to look at this one. So just now the 500 joule and 100 joule refer to the potential energy possessed by this test charge. And this 50 volt and 10 volt means the potential. There's no test charge here. Yeah, just electric field, and it's just a potential for this point. Okay, potential. So the same as for the other three diagrams. Okay, look at the value. Yeah, first of all, I want you to look at the value. Okay, so the test charge, which is nearer to the point charge, has 500 joule. As the test charge going further away become 100 joule. Okay, same as the potential. 50 volt nearer to the point charge and 10 volt further away from the point charge. The same for all the others. Can you see that? The value is bigger. The value is bigger if nearer both the potential energy and potential. Both of them have bigger value when nearer the point charge. Why is that? Why is the potential energy and potential has bigger value when nearer the point charge, but smaller value when further away from point charge? Yeah, same for all the others. You see, 550, 550, 550 on when nearer to the point charge. Why is that? Because potential energy and potential, both of them, they are inversely proportional to the distance. You see that? Do you see that? Both of them inversely proportional to the distance. So the bigger the distance, the nearer to the point charge, the higher the potential energy. The nearer to the point charge, the higher the potential. So both of them, they are inversely proportional to the distance. So that's why nearer, yeah, nearer to the point charge has bigger value, bigger value. But but the thing is, I want you to look carefully. Yeah. About now, I want you to look at the sign. I want you to look at the sign. Okay. First of all, let us look at the potential. Look at the V, the potential first. Yeah. Don't look at the potential energy first. Look at the potential. This is a positive point charge, and this is also positive point charge. Okay. So nearer to the point charge has positive 50 volt. Further away is positive 10 volt. Why is the potential has a positive value? Why is it positive value? Because as I said before, for this potential, you must substitute the sign, the positive and negative sign. And potential V only depend on point charge. So now your potential is positive sign, isn't it? Your potential, your point charge is positive. You see that? It's positive. So that means your potential is also positive. Yeah, because your point charge is positive, so potential is also positive. That's why this value 50 volt, 10 volt, 50 volt, 10 volt, they are both positive because you have a positive point charge. But look at this one. Look at the negative point charge. Negative point charge, they have negative 50, negative 10, negative 50, negative 10. Why is that? Because now you are because now your point charge is negative. You substitute negative sign. Okay. So your potential is also negative. You understand that? Because your point charge is now negative, so your potential is also negative. Okay. So that's why you have your point charge is negative. So this is negative 50, negative 10, negative 50, negative 10. Do you see that? So this potential, they all just depend on point charge. If point charge is negative, the potential also negative. Okay, now let us look deeper. Now, which one has higher value according to the number scale? According to the number scale, now I want you to look at the first case. This first case, which one is bigger value? 50 watt or positive 50 or positive 10? Which one is bigger value? Of course, like this one, positive 500, of course, bigger than positive 100. So positive 50 is bigger than positive 10. So we can say positive 50 is higher potential, positive 10 is lower potential. So same as this one also higher potential, this one lower potential. But look at this one. Okay. What about negative point charge? So which one has higher potential according to the number scale, according to your mathematics? We know that negative 100, the 500 doesn't mean that this value is bigger. According to mathematics, the more negative, the lower the value. The less negative, the higher the value. So negative 100 is bigger than negative 500. Okay. So now for the negative point charge, which one has higher potential? Is it the bigger value has higher potential? No. The more negative, the bigger the value means the more negative. The more negative, the lower the value, the lower the potential. See how important is that to understand the number scale? the more negative, the lower the potential. The more negative, the lower the value, the lower the potential. The less negative, the higher the value, the higher the potential. So negative 10 is high potential, the negativity is low potential. So nearer to the negative nearer to the negative point charge, the lower the potential. Same as this one. Yeah, same as this one. The nearer to the negative point charge, the lower the potential. But for the positive point charge, the nearer to the positive point charge, the higher the potential. The higher the potential. The nearer to the negative point charge, the lower the potential. Enough of that. Okay? Why is it positive and negative? Because for scalar quantity, for scalar quantity, you must substitute the negative sign into the charge. You must substitute the negative sign. I will explain more about this. Substitute the sign, positive and negative sign. Now, enough of the potential. Just now we talked about potential. Now I want to dive even deeper into electric potential energy, which is this one. This become a bit confusing for some of you, yeah. But after my explanation, you will understand more. Okay. Okay. So please listen carefully. Now, okay. So look at this. As I said before, electric potential energy depend on both charge, both the point charge and the test charge. Both point charge and test charge. So look at the first case. Look at the first case. Why is it positive value? Why is it positive value? Because we have a positive point charge, we have a positive test charge. So when you substitute the value, you have a positive point charge, you have a positive test charge. That's why it turned out the potential energy is positive value. Just as simple. You see that? Positive, positive, positive. So that's why it is a positive value, positive potential energy, positive potential energy. Okay, now let's look at the second case. Why is the potential energy possessed by this test charge is negative? Why is it negative? Because we have a positive point charge and a negative test charge. So when we substitute the sign into the equation, okay, yeah, let us clean this off. Now we have, now we have what? What do we have? We have a positive point charge and a negative test charge. So that means I have a positive point charge and negative test charge. That means end up with a negative potential energy. So that's why our potential energy is negative. You understand that? It's negative. Okay. Now how about this one? Now we have a negative point charge and a positive test charge. Why is the potential energy negative? Because one negative, one positive. So sir, again, come on again. So let us rub this off. Now, which one is negative? The point charge is negative, the test charge is positive. So we have a negative point charge and positive test charge. So end up we have a negative potential energy. That's why our potential energy is negative. Do you see that? Negative. Okay, the last one. Okay, the last one. Why is it positive potential energy? Why is it positive potential energy? Because we have a negative point charge and a negative test charge. So let's substitute the sign negative, negative. What do we get? I know you know the answer. So let's work it out. Both point charge, again, as I told you, potential energy need to look at both charge. So we have a negative point charge, negative test charge. So we have a negative point charge, negative test charge, negative. That's why we get a positive potential energy. And that's why our potential energy is positive. Now, which one is bigger? Which one is bigger? Okay, which one is bigger? Okay, look back to the number scale. Look at the number scale. Which one is bigger? Look at the first case. First case. Look at the first case. Which one is bigger? Positive 500 or positive 100? Of course, the more positive is the bigger, the higher potential energy. Okay, higher potential energy. This one lower potential energy. The second one, which one? The negative 500 and negative 100. Which one has a higher potential energy? Which one? The less negative. The less negative is the higher. The more negative is the lower potential energy. So the less negative is the higher potential energy. So that means the test charge, this one, the test charge, which is further away from the positive point charge, has higher potential energy. You understand? Okay, let's look at the third one. Which one has higher potential energy? The more negative or the less negative? Of course, the less negative has higher potential energy. The more negative, the lower the potential energy. And then this one, the positive 500, positive 100. The more positive one is the higher potential energy. The less the positive is the lower potential energy. Okay, now enough of that. Now comes the crucial moment. Okay, the most crucial moment is here. Just now I explained how do you generate all the which one is higher, which one is lower. That is very important because you must have that fundamental understanding before you can get the whole picture. Okay, so you already know how to get the higher value and lower value, the difference between potential and potential energy. Potential, just look at one point, which is a point charge. For the potential energy, need to look at both charge, which is a point charge and a test charge, both. Okay. So because of the formula, U is KQ over R, got two charge, point charge and test charge. But for the potential, only has point charge, one charge, which is the KQ over R. Okay, that's it. Now, you already know how to get the low and high value difference between potential and potential energy. Now, the thing is about the potential energy. Why? And the question, why is it when the test, like the first case, we have a positive point charge and a positive test charge. Why? The question is why? When the test charge is nearer to the positive point charge, it has a higher potential energy. Why? Very simple. Why? Because positive and positive, they repel each other. So we can say if the charge is nearer to when the positive charge is nearer to another positive point charge, they repel each other. When the charge is nearer to each other, the test charge has higher potential energy being repelled. When this test charge is being repelled by this repulsive force, the potential energy will convert to kinetic energy. Why is it higher potential energy become lower potential energy? Why when the test charge going further away from when the test charge going further away from the point charge, when going further away, the potential energy will decrease into lower potential energy? Because when the test charge going further away, the electric potential energy is changing to kinetic energy because it's changed to kinetic energy. Why the high potential energy drop to lower potential energy? Because the potential energy has changed to kinetic energy. when repel. Understand that? Okay, let us look at the second one. Why when the test charge is further away from the negative test charge, why when further away from the positive point charge, it has a higher potential energy than nearer when the test charge is nearer to the positive point charge, it has a lower potential energy. Why when further away it has higher instead? Because between positive and negative opposite sign charges, they have attractive force because they have attractive force. So when you these two charge which is attractive to each other, when you pull them further and further away, actually the test charge is storing electric potential energy. So when you release this test charge, this test charge will be pulled by the point charge nearer. Yeah, this test charge will automatically go nearer to the positive point charge because of attractive force. So the higher potential energy will convert to the kinetic energy as it go nearer to the point charge, to the positive point charge. So why high potential energy become low potential energy? Because when being attracted, when this negative charge is being attracted to the positive charge, the higher potential energy is changing to the kinetic energy. That's why it dropped to a lower potential energy value. Okay, that's it. So the third one, of course, the third one also the same. You have a opposite sign. The sign is opposite. When the sign is opposite, they have attractive force. When they have attractive force, when they have attractive force, then the test charge, when further away, it has higher potential energy because of attractive force. When the test charge which is further away, it has higher potential energy. When you release the test charge, it will be attracted to go nearer to the point charge, and it will convert to the kinetic energy. It will convert to kinetic energy. The higher potential energy will drop to a lower potential energy. The last case, negative, negative. Negative, the same sign, they repel, the one that repel, then the test charge, if nearer to the one that repel it, it will have higher potential energy because it will be repelled. It will be repelled away. When it being repelled away, the higher potential energy will change to kinetic energy, and then the higher potential energy will drop to a lower potential energy. Positive 500 drop to only initially it has a positive 500 joule of energy. It will drop to only remaining positive 100 joule of energy. So the kinetic energy now will have 400 joule of energy. You understand that? The total is still 500. Yeah. No energy cannot be destroyed. It can only change to the other form. So initially it has a 500 joule of potential energy. You drop to 100 joule of potential energy. So where is the energy gone? It has changed to kinetic energy. Understand? It changed to kinetic energy because why the potential energy changed to kinetic energy? Because this negative test charge is being repelled away. It's being repelled away. Okay, I explained so much about this. Now the truth here. Now this one, can you spot the one very important thing? You see, the test charge is positive and the test charge is negative. What is the relationship between U and V? What is the relationship between the potential energy and the potential? It's the same as what we have learned in electric field before. It's the same as what we have learned in electric field before. This one, remember that? If the test charge is positive, and the test charge is negative, what is the relationship between the force and the electric field? So if it is a positive test charge, if it is a positive test charge, where is it? If it is a positive test charge, the electric field and the force, has the same direction. But if the negative test charge, the electric field and the force, they are opposite direction. Do you see that? They are opposite direction. The negative test charge, when the test charge is positive, force and field is same direction. When negative test charge, the force and field has opposite direction. Now, same case to the potential and potential energy. And when you look at here, so you see for yourself. Here, this is a positive potential. This one also positive. This is a positive test charge. When you have a positive test charge, then the U and V, they are corresponding. What does it mean by corresponding? That means if the potential is high, the potential energy also high. And then when potential is low, the potential energy also low. Is it the same? You see, the positive test charge, high, high, low, low. Low, low, high, high. Correspond, you see? High potential energy. Low potential energy. Why is that? Because because of this meaning, potential is actually regard the test charge as a positive test charge. That's why they correspond. You understand? Because initially the definition of potential, it regard the test charge as a positive test charge. That's why they correspond. That's why high, high and low, 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 low and high, high. But if it is a negative test charge, then you see what happened. You have high potential, but the negative test charge has low potential energy. But when you have low potential, the test charge will have, the negative test charge will have high electric potential energy instead. High, low, low, high. Same as this one. You see? Low potential, the negative test charge has high potential energy. High potential, the negative test charge has low potential energy. Low, high, high, low. So inverse. If negative test charge is inverse. Okay? So that's the thing I want you to some hidden. These are actually hidden concept, not taught by many lecturers, but it's quite important for you to know for this. What I think, yeah. So I'm glad if you understand. If you don't understand, you can leave a comment below, and I try my best to explain more in the comment. Thank you for your time. Thank you for your patience. Continue with the next video. Bye.